Circulation. Next, in our continuing series on swimming pool instruction, is the importance of good circulation. Circulation is the movement of the pool water through the pump and filter system. In contrast, the term turnover refers to how long it takes for a given amount of water to pass through the pump. It is recommended for pools to have an 8-hour turnover. This means that when the pump is running, it will take 8 hours for the net volume of water in the pool to move through the pump and filter system. It is important to note that turnover does not mean that all of the water in the pool went through the pump and filter. It could be the same water over and over, which is what happens when water is not properly circulating. The growth of black algae can be evidence of slow or dead spots in the pool that occur because poor circulation to those areas causes insufficient amounts of sanitizer or algicide to reach the areas frequently enough to be effective. There are several things you can do to help assure proper circulation. Keep the bottom or main drain open so that a larger portion of the total pool water volume is being drawn through it. The skimmers then handle the rest. Adjust the return line fittings so that they direct the water flow in a generally circular pattern around the pool, and also aim 1 or 2 gently downwards to improve water mixing from top to bottom, but also aim 1 or 2 upwards to ripple the water. This last point is critical in pools with no main drain or where the main drain no longer functions due to age, restrictive bylaws, or some other problem that is unable to be corrected. Water outlets. Water outlets are any pool opening where water goes out of the pool for circulation. Some examples are: 1. Skimmer. The skimmer is used to circulate water from the top of the pool and to skim debris off the water surface. It is critical that the skimmer be in good operating condition and functioning properly. The skimmer basket must be in place at all times and free from damage, and the skimmer weir, flap in the throat of the skimmer that maximizes skimming action, is in place and working freely. The skimmer is the place we recommend that you use to vacuum the pool to ensure any large debris that may be vacuumed up is caught in the skimmer basket, thus avoiding a potential plug circulation line. 2. Main drain. The main drain is typically located at the deepest point of the pool and is used to lower the water level. However, its primary purpose is to circulate water from the bottom of the pool. It is recommended that about 1/3 of the circulated water come from the main drain. Some residential pools do not have main drains, instead of relying on a deep water outlet to drain the pool and for extra circulation. 3. Deep water outlet. A deep water outlet is located on the lower portion of the side wall and is used to circulate water and to lower the water level. A great insert fitting must be installed to prevent suction entrapment. 3. Vacuum outlet. A vacuum outlet is installed on some pools and is intended to be used primarily as a suction port for vacuuming the pool. Extreme care must be taken when vacuuming a pool through the vacuum outlet so as not to vacuum up large debris that may become lodged in the circulation plumbing. We recommend you vacuum through the skimmer using a vacuum plate and skimmer basket if large debris is a concern. Circulation pump. Your pool has a circulation pump that is responsible for moving pool water throughout the circulation system. This is not to be confused with auxiliary pumps, such as cleaner booster pumps, jet pumps, waterfall pumps, etc. Water is drawn in from the pool's inlets into the front of the pump, through the hairline trap, then through the pumping chamber, and finally out the top of the pool pump on its way to the filter. Above ground pools, and in rare cases, in ground pools, have flooded suction pumps. These pumps need to be located below the pool water level because they are not capable of pulling a prime on their own and depend on gravity to keep them primed. The only maintenance for a circulating pump is to clean out the hairline trap basket as necessary and to lubricate the hairline trap lid gasket or O-ring with an on-petroleum-based lubricant about once a month. There are 6 steps for determining what size pump is right for your pool. 1. Determine the number of gallons of water in your pool. The formulas for calculating the gallons depend on the shape of your pool. There are pool volume calculators on the internet. Many manufacturers supply simple calculators to help you determine which size pump to order. For example, the formula for calculating the total gallons in a round pool is gallons equals sine diameter multiplied by average depth multiplied by 6. So, if your pool is 25 feet in diameter and is 4 feet deep, the pool's capacity is 25 feet by 25 feet times 4 feet times 6 equals 15,000 gallons. 2. Determine flow rate. Determine how many gallons per hour you need to pump to clean all the water in your pool in 8 hours. To determine flow rate, Divide your calculated gallons by 8. For the round pool example just given, the gallons per hour is 15,000 divided by 8 hours, or 1,875 gallons per hour. 3. Calculate gallons per minute. To convert from gallons per hour to gallons per minute GPM, divide your gallons per hour by 60 minutes. In our case, 1,875 divided by 60 equals 31 gallons per minute. 4 feet of head. You next have to figure out the average feet of head by determining the total length of pipe in your system for your pool pump. Feet of head is the total of pipe length plus valves and turns plus filter and heater drag. For example, pipe lengths and rise equal 28.0, valves and turns equal 4.7, cartridge filter 70 SQ equals 7.5, heater equals 7.5, total feet of head equal 47.7. 5. Determine pump size. You now have the information required to select the size of your pool pump. Go to the description page of the style of pump you would like to purchase. Many pump manufacturers will provide a chart on this description page showing the horsepower required for your particular gallons per minute and foot of head. For example, based on our example for a typical round pool, we are looking for a pump that will handle 31 gallons per minute with a 47 feet of head. According to the typical chart for 50 feet of head closest to 47, we need a pump between 3/4 horsepower pump. 6. The size of your pool filter is directly related to the pool pump you have selected. If your pool filter is too small for the pump, there will be additional strain on the pump motor as it tries to push water through and encounters resistance at the filter. This will eventually burn out the pump motor and your filtration will also be compromised. We recommend selecting the filter so that it is oversized to be absolutely certain it can handle the flow coming from the pump. So, in this case, instead of getting a filter rated at exactly 31 gallons per minute, you should select one that is a little higher. These calculations are based on a basic pool configuration with no extra water features like fountains, spas, waterfalls, solar heating, and in-floor cleaning systems. These features generally require a higher HP pump.